I'm going to go over some of the work from today because there were a couple of students who missed class. Please make sure that you go over the proof for the definition. Apparently there's a very good one on the Learning Hub in Atomi. There's our proof of sin x, and that works because down here we know these things, sin h over h will equal 1 and cos x approaches 1. So we get a nice, that's a pretty good proof of that, but go and look at the vision on Atomi if you want to get a better one. Once we understand that, we can do cos, because we can use the complementary angle. Sine of an angle is cos of its complement, or cos of an angle is sine of its complement, same thing. And that's a pretty easy one to do. And then, of course, tan x, which is just sin x on cos x, and you can use the quotient rule to get that out. Right, I very quickly want to do a couple of these ones. I'm going to do the first one here, and then I'll do a couple of the others. Please remember, I want you by tomorrow to be up to question 13. So I'm going to look at some of the ones in question 1 first. So I'm going to do 1a. I'm going to do 1a using substitution. So I've got y equals sine 4x. I'm going to show you why this works. If I let u equal 4x, du dx equals the derivative, that is 4. And therefore, y equals sine u, and I know that dy du equals cos u. But what I'm after is dy dx, and I know dy dx is dy du times du dx. And remember, that's not cancelling, it's a chain rule that we worked out before, which gives me cos u times 4 cos, and I'll substitute 4x back in for u, 4x. And there's the first one. Well, we're not going to do that every time, because all we have to realise is that we just take the derivative of what's inside that function. So my law is going to be, for any of these trig functions, and I'll use sine, if y equals sine some value f of x, or y dash equals the derivative of what's in there, f dash of x, cos f of x. So you're just going to multiply by the derivative. Let's have another go. Let's try d, which is y equals tan 3x plus 1. So we don't need to go through all this now. We just go, well, y dash equals the derivative of what's in there, the derivative of that, which is 3. And then we just change that, so that's going to be sec squared 3x plus 1. Oh, so it's pretty easy. Yes, so let's jump down now to h, which is y equals 2 cos x cubed. Now, it's very important that x cubed is actually contained in there. It's not cos cubed x. It's a different thing altogether. So y dash equals 2 times 3x, the derivative of what's inside, squared. And the derivative of cos is minus sine of what I had, which is x cubed. And I'll tidy that up, and I get minus 6x squared sine x cubed, to make sure that 3 is contained in there. All right, the next hard one to do is really L, and L requires the product rule, x tan x. Oh, that's pretty easy. This is y dash is the first x times the derivative of the second, sec squared x, plus the second tan x times the derivative of the first, which is 1, done. Well, let's make it a bit harder. Let's use our, because there was one that was squared. I just have to have a look here. Maybe it was before that. Yeah, I'm going to jump down to Q. So Q is y equals sine squared x. Well, there are two ways you can do this. You can write that as y equals, now that square is in a different spot, that means sine x times sine x, so you could use a product rule, or you could consider that this is y equals sine x all squared, and we can use a fat finger rule. I think it's going to be much easier to use a fat finger rule, so here we go. Y dash is 2 sine x to the 1 times the derivative of what's inside cos x, which gives me 2 sine x cos x. And does Margaret change that back? What is that? Q. 2 sine x cos x. No. We could write that as something else, but we're not going to. Sweet. That was pretty good. Let's have a go at a couple more, and then we'll move on. Let's do R, which is 3 cos cubed 5x. So y equals 3 cos cubed 5x. Again, think of that like this. Y equals 3 cos 5x all cubed. Okay, so the derivative is, let's bring that 3 down the front from the top, times the 3 that's already there. We keep the cos 5x because that's a fat finger rule. We take 1 away, 2. Now we multiply by the derivative of what's inside, and that's negative 5 sine 5x, which gives me 3 times 3 is 9 times 5 is negative 45 cos squared 5x sine 5x. Let's just check that. Yes, she's got this. Margaret's got the sine x first, but that doesn't matter. Okay. I'm going to cruise down here a bit further now because I want to get I'll do u, v, and x. U, v, and x. So u sine e to the x plus x, y equals sine e to the x plus x. Well, again, y dash, it's cos e to the x plus x times the derivative of what's inside. Oh, e to the x plus 1. So e to the x plus 1, I should have put it out the front from the beginning, cos e to the x plus x. You could expand that. I'll just check, see if Margaret did that. No, she didn't. That's easy. What do we got? V. V, I've got y equals log to the base e sine x. Well, I like to write that as y equals ln sine x. And remember, if you do your fat finger rule, again, there's your fat finger going all over that. Well, not fat finger rule. If you use substitution and you went let u equal sine x, you get ln a u. So you differentiate it and you get the derivative of the function. Well, what's the derivative of sine x? Cos x over the function itself, sine x. Oh, and we know that cos x over sine x is cot x because it's a reciprocal of tan. So we get the derivative there, cot x, did Margaret write it like that for v, gv? Yep, cos x on sin x. And finally, I'll do x, which is e to the 2x on tan 7x. So y equals e to the x on tan 7x. Well, this is good. We get a chance to do the quotient rule. Y dash, put your dash in the right spot. Y dash equals the bottom, tan 7x, times the derivative of the top, e to the x, minus the top, e to the x, times the derivative of the bottom, sec squared x, all over the bottom squared. Oh, sorry, that should be 7 sec 7 sec squared 7x, all over the bottom squared, which is tan squared 7x. She factorises the e to the x out. You can do that and you get e to the x outside of tan 7x minus 7 sec squared 7x all over tan squared 7x, but I don't suppose it's going to make much of a difference. Righto. So, 2 is a product rule. You can take time on that. 3 we did in class. 4 I'm going to do, and then I might have a look at 1 or 2 of these other ones. So 4 was y equals sine pi minus x. So this is your standard. Here's question 4. So y equals sine pi minus x, and we're doing this at the point pi on 6.5, pi on 6.5. Well, the first thing we have to do is differentiate this if we're going to find, and what do we find in the equation of the tangent, and we want it in exact form. So we'll differentiate it. So we get y dash equals cos pi minus x, and we're multiplying by the derivative, which is -1. So I'll put a negative in front of it. Now, that's a gradient at any point. We needed it when x is pi on 6. So when x equals pi on 6, we get our gradient m of the tangent equals negative cos pi minus pi on 6. Now, let's go here. Remember, there's pi. That's pi minus theta, and that's pi plus theta, and all stations to central. That means we're going to get a negative in there. We're going to get a negative when we do it here because it's in this quadrant and it's cos and only sign is positive there. Well, what are we finding? Well, pi minus pi on 6. Here's our little right angled triangle. There's pi on 6, and that's 1, and that's √3, and that's 2. So cos is √3 on 2. So it's going to equal minus √3 on 2, which gives us positive √3 on 2. And that is the gradient of the tangent. What do we need? We need the equation of the tangent. So y minus y1 equals m outside of x minus x1. So they'll give us y minus a half equals √3 on 2 x minus pi on 6. So I've just substituted this point in and this gradient. And what do I get? Well, let's multiply that 2 across, and I get 2y minus 1 equals √3x minus √3 pi on 6. Now, I'd be happy with that, but in the back of the book, Margaret says, well, we don't like that fraction there, so we're going to multiply everything by 6. And if we do that, we get 6 times 2 is 12y, 6 times 1 is 6, 6 √3x, and the 6 will just disappear from here, leaving us with minus √3 pi. And if I look at question 4, Where's the equation of the tangent? Root 3 6x minus, yeah, okay, that'll do. Now, what are some other ones here that I think might be hard? That's as far as we got today. Differentiating log cos x, yeah, that's okay, should have a go at that. The equation of the normal. I think I like question 8 and 9. 8 and 9. Normal to the curve. Find the equation of the normal. No, I might let you do 8. I will do 9 and I will do 12. You go and have a go at them yourself though. So 9, I've got to do 2 derivatives as y equals 2 cos 5x. So I'll go down here. Here's question 9. Y equals 2 cos 5x. Let's double check, make sure we got the right question. 2 cos 5x, and I've got to show that that's minus 25y when I do 2 derivatives. Okay, well, do y dx, first derivative, is cos goes to negative sign, so we're going to have negative. The derivative of the 5x is 5 times the 2 sine 5x. Woo! So negative 10 sine 5x. Actually, you know what I'm going to do? I'm going to leave that as minus 5 times 2. You'll see why in a minute. Okay. d2 dy dx squared, the second derivative, equals, okay, this whole thing, minus 5. Well, first of all, I've got to multiply by the derivative. So 5 times minus 5 times 2. Sine goes to cos 5x. All right, I'm going to multiply the 5, so I'm going to get minus 25 times 2 cos 5x. Oh, Mr. Tonkin, why aren't you just multiplying that 2 and getting 50? Because I had to show something. I had to show that y dash, well, the second derivative equals minus 25y. And because I've left that like that, oh, look, they're the same. I can just jump in and I can say minus 25, and that's my y, which is what I was required to do, as required. All right. Now, what did I say I'd do? I said I'd have a quick go at, I think it was 12. Find the coordinates of stationary points. Find the coordinates of the stationary points. I could draw it, but I'll have a go. What do we got? Y equals 2 sine x minus x. So here's 12. Y equals 2 sine x . 2 sine x minus x. Okay. I'm going to have to derive this twice. So I'm going to, y dash is 2 cos x minus 1, and y double dash is minus 2 sine x. Well, stationary points when y dash equals 0. So 2 cos x equals, minus 1 equals 0. 2 cos x, take the 1 over, divide by it, cos x equals a half. All right, triangle, 1, 2, root 3, pi on 3. So x equals inverse cos of a half, which equals pi on 3. But we also know this is going to go round, so how many do they want between what and what? between 0 and 2 pi. Well, we better grab another one. So we'll grab this other one, and we know that all stations to central, the other time is at 2 pi plus pi on 3, minus pi on 3, so we get pi on 3, and we get, well, 5 pi on 3. Well, what happens at those stationary points? Well, when x equals pi on 3, y double dash equals what? What do we got here? Minus 2 sine x. Minus 2 sine pi on 3. Well, sine pi on 3 is root 3 on 2, which is minus 2 root 3 on 2, which is less than 0. So that is a max TP. Well, when x equals 5 pi on 3, y double dash equals minus 2 sine 5 pi on 3. Well, that's the same, but it's negative. So it's negative 2 times negative root 3 on 2, which is positive 2 root 3 on 2, which is greater than 0, therefore a minimum TP. Now let's double check. Question 12. Oh, I had to find the y values. Better go along here. Y equals, what was it? 2 sine x minus x. 2 sine pi on 3 minus pi on 3, which is 2 root 3 on 2 minus pi on 3, which gives me root 3 minus pi on 3. So this point is pi on 3 and root 3 minus pi on 3, and it's a max. Righto, let's do this one. Y equals 2 sine 5 pi on 3 minus 5 pi on 3. Well, we know that that's negative, so it's going to be 2 times negative root 3 on 2 minus 5 pi on 3, which gives me negative root 3 minus 5 pi on 3. So this point is 5 pi on 3 for my x, and negative root 3 minus 5 pi on 3. And that was a minimum. And they're the stationary points, and that's what they are, and there are the answers. Now, hopefully you had a go at that. Hopefully you've done lots of the questions from question 1, especially if you missed it, and that you're able to do up to and including question 12 by tomorrow. It's pretty important. Good luck.